Okay, so we are going to go through the steps. So steps for solving absolute value equations: isolate the expression that's in the absolute value. You always do that first. Then make two equations, then solve, then always check your answers. This is a big one. This is like when we did the radicals and the rational equations. Sometimes you don't have a solution, like if it equals a negative number. If you don't happen to notice that while you're solving, the best way to make sure that you do notice it is by checking your answers at the very end. So you would plug them back in, and if it doesn't make sense, like they're not equal to each other, then that means no solution, or maybe only one solution. So you need to check them both. All right, so I'm going to use blue. All right, here we go. Solving absolute value equations. First example, you have the absolute value already isolated. When they say isolate, they mean get the part that is in the absolute value bars all by itself. I like to have it on the left-hand side. You can have it on any side that you want. From there, you are going to create two equations. When you make the equations, you don't need the absolute value bars anymore. So you can just write c minus 15 equals 23 and c minus 15 equals negative 23. Like that. So now you are going to solve for c. So you're going to add 15. That goes. 23 plus 15 is 38. And then you want to add 15 on the other side. Those go. So c equals negative 8. Okay. All right. Yeah, we need to check them. So check when you plug them in. So go back to the original, put the absolute value bars. Okay, that's important. So 38 minus 15, when you take the absolute value of that, is that 23? Sure is. Absolute value of 23 is 23, so that's good. And then if you do the other one, it would be negative 8 minus 15 with absolute value. Does that equal 23? Yep, because that would be the absolute value of negative 23, which is 23. And those both check. So you got two answers. 1, 2. Okay, remember doing this in Algebra 2? It's been a while. I'm sure it's been a while. All right, once you have that, let's go down to example number 2. So now we need to get the absolute value all by itself. There's a little plus 8 hanging out next to it, so we need to get rid of him. So we're going to subtract 8 first. Make sure you do that. So this would be absolute value of 5 minus x equals negative 7. Well, let's look at that. You have an absolute value. Now it's by itself, right? You have an absolute value set equal to a negative number. So right now, that is going to be like red flag, alert, warning. That's never going to come out to be a negative number. So this is going to be no solution. Okay. Now, let's say you didn't notice that and you were just like, going along doing your algebra. When you check your answers, you'll see that the solutions don't work. I went ahead and solved it just to show you the check. And so when you solve this, you get x equals 12 and you get x equals negative 2. When you plug that back in, you're going to get the absolute value of 5 minus 12, like that. And this is why it's really important that you go back to the original equation. Oh, I'm sorry. I totally didn't go back to the original equation, did I? go back to the original equation. So that would be absolute value of 5 minus 12 plus 8. Does that equal 1? That was the original. So this is the absolute value of negative 7 plus 8. Does that equal 1? Well, when you take the absolute value of negative 7, that becomes positive 7. 7 plus 8 does not equal 1. So therefore, that throws that answer out. And then if you check again with the negative 2, this would be absolute value of 5 minus negative 2 plus 8. Does that equal 1? Well, 5 minus negative 2 is 7. The absolute value of 7 plus 8, which would be 7 plus 8, that's not going to equal 1 either. So if you check your work every time, you're going to come out to the same conclusion, which it's just no solution. Okay. Now, if you notice it early on, it saves you a whole bunch of work. So try to be super observant. Okay. All right. Let's fill this in. So solving absolute value inequalities. So I think it's really important that we talk about what these things actually represent. Like, why does the answer come out to be the way it does when you have the less than and the greater than sign? So part A says verbally describe what the absolute value of x is less than 3 really means, actually means based on the definition. Well, this means the distance from 0. That's what that really means. The distance from 0. And then you're going to say is less than, because we have a less than sign, 3. Well, what does that mean? That means that all the possible answers have to be a distance of less than 3 away from 0. So if you drew a number line, okay, you're going to put 0 on your number line. And actually, I guess I should be putting this down at the bottom, shouldn't I? I'm on to, so part A was just talking it out. So we should put our number line if we want to have everything placed correctly down here. Okay. Because this would be part of helping us do our interval notation and our set builder notation, all that good stuff. So what does that actually mean? So you put 0 on your number line. Now, if the answers, if all the solutions have to be less than 3 units away from 0, then that means, let's see, we go 1, 2, 3, right? So they can't actually be 3 units away. So I'd have to put an open circle on that. They could be 2.5 units away. They could be 2.9 units away. They could be 2.1, 1.5, 0.9 units away. They could be 0.1 units away. They could be 0.0001 units away. So it could be all of these answers, right? Everything less than 3. All those decimals and fractions and irrational numbers in between 0 and 3, they are all less than 3 units away from 0 on the number line. So that's why we shade all of that. Well, not only can we go to the right, we can go to the left too, right? So, correct? So you'd go -1, -2, -3. It couldn't be all the way to the left, -3 units, but so we'll put an open circle. But we could be -2.9 units away. We could be -2.5. We could be -1. We could be -0.5 units away. And so all those numbers in between -3 and +3 are possible solutions for being less than 3 units away in distance away from 0. So that ends up being your solution, okay? So how do you express this as an inequality? Well, the inequality would be -3 is less than x is less than 3, like that. Well, if I were to take that, that's a compound inequality because you have two less than signs. So if I wanted to make it into two like singular inequalities, two like separate individual ones, that would be you'd have one that would be x is less than 3. And then the other inequality would be negative, let's see, let me put it over below there. The other one would be negative 3 is less than x, but that looks kind of funny. Like we don't normally read inequalities like that. Usually the x is on the left-hand side, right? So if we want to move this to the left-hand side, you put the x over on the left and then you flip the sign. So x is less than 3 and x is greater than negative 3 is another way to express that inequality. And it so happens to be how you solve the inequality. You take what you have and you make two equations. Rewrite it identical to what you started with, and then flip the sign on the second equation, right? And then make this negative. Okay? So it all comes from the definition of absolute value. That's why you end up having to flip the sign, because you're going to have values on the right and on the left that are going to satisfy that definition. Now, we did inequalities, we did a graph. Let's talk about set builder notation and interval notation. Your set builder notation, that's the one where, let's see here, where can I squeeze this in? I guess I'll put it right here. So set builder notation is going to be the curly brackets. You put an X and then you put such that. You can put a colon, you can put a line, and then you use this one down here. That's probably the best one to write. It's the most efficient way to write your answers. Okay? That's the set builder notation. Interval notation is where you use like the brackets and the parentheses. We talked about that yesterday. That should be a review. So your interval notation for this one will be parentheses, -3, comma, +3, parentheses. Okay. Alrighty. We'll move on. If you need to take a screenshot of that, feel free. All right, so now let's go down here. This is just going to sum it up in the box for you. So that way you can just have a go-to for how to solve. So this works for less than, greater than, less than or equal to, either one. So if the absolute value of u is less than a is equivalent to, okay, so this box is just the less than kind. So this is going to be -a is less than, is less than u is less than a, like that. If it's the less than or equal to, it'll be -a is less than or equal to u is less than or equal to a. All right. And in other words, the absolute value less than a is equivalent to u being less than a and u being greater than, oh my goodness, lost it. There we go, -a, like that. Okay. All right, so we have a few examples. It looks like I have 1, 2, 3. We have 4 examples left, and then you're gonna work in groups on a little assignment, okay? So let's check this out and make sure that you ask questions if something doesn't quite make sense, okay? I got the chat open, so I will try to make sure and glance down at it often. All right, example 3. Solve the inequality. The absolute value of x minus 15 is less than 23. We're going to use set builder notation and interval notation, and we're going to graph it. So you're going to do the absolute value is all by itself. So this is going to become 2 equations. So x minus 15 is less than 23. And x minus 15 is greater than negative 23. Okay, add 15 to both sides. So x is less than 38. And then add 15 to both sides. X is greater than negative 8. Okay. So I like to graph it right after I come up with my solutions. So that helps me do my set builder and my interval notation. So if we do the graph, we make a number line. You're going to put negative 8 on there somewhere, and we'll say 38's right there. These are going to be open circles because we don't have the equal to part. So open circle on negative 8, open circle on 38. Less than 38 would be shading to the left, and greater than negative 8 is going to be shading to the right. So these are going to overlap. Okay. And every time you have a less than or equal to, your solutions are going to overlap. So overlapping solutions are when you have less than. When you have greater than, which we're coming to here soon, then they're going to do something else. So your interval notation would be parentheses, negative 8, comma, 38, like that. And your set builder notation would be little curly brackets, x, line, and then we can write this as negative 8 is less than x is less than 38, okay? You just take your number that's on the left and you put it on the left-hand side of the inequality, take the number that's on the right and put that on the right-hand side of the inequality, put the x in the middle, you're good to go, okay? This set builder notation is getting us ready for doing more domain problems. I don't know if any of you noticed that, or maybe that made you recognize that from doing domain in the past. But that's why we're doing set builder notation, get us ready to do more domain problems in the next chapter. All right, let's look at the next one. Example or exploration 3. So what does it mean verbally for the absolute value of x to be greater than 4? Okay, so that means the distance away from 0 is greater than 4. That's what that actually means. So all the numbers on the number line that are a distance greater than 4 units away from 0. That's what you're doing when you're solving that absolute value. So let's take a look at it. Okay, so I put 0 on my number line. Now, my answers have to be a distance greater than 4. So 1, 2, 3, 4. There we are. There's 4. They can't be exactly 4 units away. So I'd have to put an open circle on 4. But anything farther away than 4 works because that would be greater, a distance greater than. So like 4.1, 4.5, 5, 6, 7, 10, 30, 100, infinity. Anything, any of those, infinity is not really a number, it's just an idea, but It is greater than 4 units away from the 0. So all of these numbers get shaded, and I'm really like over exaggerating. But everything all the way out to the right is going to be a solution because it's a distance greater than 4 units away from 0. Well, if we can do that on the right, we can do it on the left too, because distance is always positive. So if we go 1, 2, 3, 4 to the left, I can't be exactly 4 units to the left, but I can be farther than that. So all of these numbers, all these fractions, all the decimals, all the irrational numbers, everything, all of those numbers all the way out to approaching negative infinity would be a possibility because they're all greater than 4 units away from 0 on the number line. Okay? So this one, they don't overlap, do they? They point away from each other. So the answer could be over here, or the answer could be over here. Like you could pick one or the other, right? And get an answer. So when we do our interval, I'll do interval notation first. When we do our interval notation, you're going to have to do 2 intervals, one for the left-hand side and one for the right-hand side. So the first interval would be negative infinity to 4, and then you're going to put in union with parenthesis 4 to positive infinity. Okay, the big old U means in union with, and it joins your answers together. Your set builder notation is going to be all x such that, now for this, you can write, you would have to write it out. So you would do, let's see, we'll do the easy one. We'll do the one on the right first. So x is greater than 4, and then you're going to say or x is less than, oops, I forgot the little negative sign there. Sorry about that. Notice that you need a little negative sign right there. I forgot mine. X is less than 4, negative 4. So you actually have to write out the word or for your set builder notation when they point away from each other. Okay? So x is less than negative 4, or x is greater than 4. And that ends up being how you solve the absolute value. If you have the absolute value is greater than 4, the 2 ways, the 2 inequalities you set up is one that is identical to what you start out with without the absolute value bars. And then the second one, flip the sign and negate the 4. Excuse me. Any questions about that? Okay, cool. All right, so now we're going to move down to the box. So we have inequalities of the form greater than or greater than or equal to. So if the absolute value of u is greater than a, then that is equivalent to u being greater than a or u being less than negative a. No compound inequality for that one because they don't overlap each other. So we have to write the 2 inequalities separately. And it's the same thing. When you have the equal to part, you still do the same thing. U is greater than or equal to A, or U is less than or equal to negative A. All right. Okay, so let's do example 5. So for example 5, you're going to solve the inequality. So right now, this is all by itself. So we're going to make, let's see, I'll rewrite it down here. We're going to make two equations. So negative 2x plus 1 is greater than or equal to 9, and negative 2x plus 1 is less than or equal to negative 9. Okay, be careful with your algebra, of course. You're going to subtract 1. So negative 2x is greater than or equal to 8. And then divide by negative 2, like that. We're dividing by a negative number, like what we talked about yesterday. So flip the sign, don't forget. So this will be x is less than or equal to negative 4. Over here, if we subtract 1 from both sides, we're going to get negative 2x is less than or equal to negative 10. Then divide by negative 2. Oh, we've got that situation again, so don't forget to flip the sign. So x is greater than or equal to, positive, not negative. That will be positive. Positive 5. Okay. All right, so we're going to graph that. When we graph it, we were going to put negative 4 on there, and we're going to put 5 on. So 5 is going to have a closed circle, and so is negative 4 because we have the equal to part. Everything greater than 5 will shade to the right. Everything less than negative 4 will shade to the left. Set builder notation will be x such that, and this is the kind where you write like two separate ones. So x is less than or equal to negative 4, or x is greater than or equal to 5. Okay. Interval notation. You got to do two intervals, right? So we're going to go, we always go left to right, okay? So negative infinity up to negative 4, put a bracket on that one because you have a closed circle. In union with bracket 5 to positive infinity. Okay. Take a minute or two, look at that, make sure that you're feeling good about it. Any questions? You can, yep, good. Put it in, you can put it in the chat, or you can just unmute yourself if you want to. All right, good deal.
I'm good.
Awesome. Good to hear. Okay, so let's go. This is the last example until you're on your own. Till I throw you to the wolves and you're in your breakout rooms. No, just kidding. You're going to be fine. Okay, so the last one, we have to get that absolute value all by itself. Right now, there's -5 hanging out behind it, so we got to take care of that. So this is going to be absolute value of negative w plus 3 minus 5 greater than or equal to 2. Add 5 to both sides. Okay, add 5 to both sides. So this is going to become absolute value of negative w plus 3 greater than or equal to 7. Now make two equations. So negative w plus 3 is greater than or equal to 7, and negative w plus 3 is less than or equal to negative 7. Subtract 3 from both sides. Negative w is greater than or equal to 4. Subtract 3 from both sides. Negative w is less than or equal to negative 10. All right, you got negative W, you need positive W. So you're gonna divide by -1 on both sides, and you're going to remember to flip the sign. So that goes, so W is less than or equal to -4. Then the other one goes over here, W is greater than or equal to 10. Let's make a graph. So we're going to put -4 on here. We're going to put 10 on here. We have equal to parts on these, so closed circles filled in. Everything less than -4 is going to shade to the left. Everything greater than 10 is going to shade to the right. Okay. We have 2 intervals. So when we do our set builder notation, it's the curly brackets with an X and then a line such that X is less than -4 or, less than or equal to, -4, or X is greater than or equal to 10. Okay. Interval notation, you're going to need 2 intervals. So left to right, -infinity to -4 with a bracket in union with bracket 10 to positive infinity. Okay. Any questions on that?
No, ma'am.
Awesome. Good to hear. All right, so I'll give you like a minute there to take a look at anything. And all right, let's see. Yep, that one's good. Okay. So now it's time to break up into groups. And so let's see here. Do we have, I think we might have like uneven groups a little bit here. I'm just going to go random generator. And let's do maybe 4 groups. 4 groups of 3. Maybe one of those groups is going to have 4 in them because I think we have, well, actually, maybe we do have more. Maybe we can. Well, we'll do that. We're going to go 4 groups and see how it works. So I am going to create the rooms. Have y'all ever done breakout rooms before in your other classes?
I have.
Okay, cool. So what's going to happen if you haven't? Okay, it's totally okay if you haven't. What's going to happen is it's going to pop up on the screen for you to join your room, and you just go ahead and click the button, and then you'll automatically be put into your own little private Zoom room. And I can pop in and out, but nobody else besides you and your group members will be in that little room. And there's a little, you can like ask me a question. You can send me a message and be like, hey, come to our group because we need help, that kind of thing. And I'll get it. And then I can pop in and help you. But other than that, nobody else in the class can hear you talking or see your screen or anything. So you're going to see a little box pop up on your screen that says join whatever room. It might even show up in the participant box. So if you don't see it pop up on your screen, then look in the participant box and there might be a little thing next to your name that says you need to join. And so let me know if you don't see it and I'll help you out. It's a little different from my end. So like, I don't see the same thing you do, but I'm pretty sure I can help you through it. Okay, here we go. I'm hitting the button now. Oh, by the way. So where's the assignment, right? I need to tell you what that's going to be before we all leave each other. So I'm going to type it in the chat. All right. So let me make sure it's going to everybody. So in Canvas for today, it says Zoom classwork, and there's a PDF of a worksheet that's got like, I don't know, 30 some problems on it. We are not doing all those. We are just doing some of them. So these numbers that I am typing in the chat are the only ones that you're responsible for. While you're waiting for me, you can open up the Canvas module for today and find that PDF. Okay. So the only thing you need to do for today is those 10 problems from the worksheet that I posted in Canvas. I wonder if I could, I don't have it in my Google Drive. Next time I'll share the file in the chat. But it would take a little bit for me to get to it right now, but it's in the Canvas module. So, okay, are we all good? I'm going to move you into your groups now, and I'm going to stop the recording.